Welcome to myprojectbazaar.com. Our project title is Optimal Secrecy Capacity Delay Trade-off in Large-Scale Mobile Attack Networks. This is our abstract. So first of all, we investigate the impact of information theoretic secrecy constraint on the capacity and the delay of mobile attack networks, that means MANET. So the MANETs with mobile legitimate nodes and static eavesdroppers whose location and channel state information, that means CSA. CSA means channel state informations are both as unknown. So here we assume legitimate nodes move according to the fast. So here there are also static eavesdroppers located uniformly in the network, and we assume the number of eavesdroppers is much larger than that of legitimate nodes. So here the data is passing to the nodes. First of all, if you know about the data's network is the data transmission through the source and destination, but the source and destination of the data is do not passing directly. The data is passing to the routers. The routers are called nodes. So here the eavesdroppers is much more larger than the legitimate nodes. So here we propose a novel, simple, secure communication model. That means the data is splitting using the duplex algorithm. The duplex algorithm using the data splitting for the secure communication model. So after the data's fragmentation, the data is passing to the routers or nodes. So here the secure protocol model and prove its equivalence to the widely accepted secure physical model under a few technical assumptions. So here, based on the proposed model, a framework of analyzing the secrecy capacity and the delay in MANETs is established. MANETs means mobile attack networks. Okay, so this is the architecture of the MANET, that means the mobile attack networks. So the mobile attack network means the data shared from the source and destinations through the router. So first of all, we are passing to the data, that means the file transfer mode. File transfer as the user upload. So the user upload means the user is selecting some particular process, that means the particular data will be fragmented, so is called through the service level agreements. So some are the basic principles based the data is going to be uploaded, that means the files are splitting by the data owner. So here the data owner splitting the particular files, that means the data owner is splitting the particular files through the routers. So here the routing IP configuration algorithms, the routing algorithms based, we will implementing how to split the data on to be passing to the routers. That means the cognizant of all facts, that means routing IP address configuration algorithms. So here the routing algorithms based, we will implementing our data, that means routing algorithm through we will passing our splitting data on multiple routers. So after the selection of the nodes user, that means router selection. So after the router selection, the lowest RC in combination based, we are passing our data, that means the data is passing on the networks on the peer-to-peer networks. So the peer-to-peer networks means the data shared from the source and destination. So first of all, the starting peer network is through the some routers techniques, routers 1 and routers 2. So the number of routers based, we are passing our data on the combinations. So after the when the users are download the files will be merging because we are not passing a single data on single routers. So every router is splitting data to be passing. So finally we are not using the splitting data. So finally we will get the only file merging operations to be performed. So after the file merging, we will analyze the performance, that means how to split the data on the duplex algorithm. So the duplex algorithm uses how to we will calculate the analyze performance to be analyzed. Okay, now the demo section is start for the optimal secrecy capacity delay trade-off in mobile attack networks. Okay, so this is the username, so this is the password to login. So this is the valid user. So choosing the type of file, Okay, is the PDF file name. Yes, proceed. So data owner, so type of files, so even data 7. Okay, so access the file. So the user file is given to the data owner to split the files. So file selection, so node formation, so is equals to 50, so number of files is equals to 14. So get the node selection. So this is the random number based the node selection. So PDF data, so file transferring, so this is the number of files equal to 14. So the replication nodes will be performed. Okay, PDF. Okay, so this is the replication process. So type of file. So next, so get the file. So get the file from the data owner. So this is the data owner process. So this is the original file. So this is the splitter files. Go for next. So get the file request for the files. Okay, so yes, so this is the authentication. So the username is Arun, password is Arun, file name is equals to drops.pdf. So verify it's a valid file name. Okay, so when I click to the view content, it takes some more times. So I choosing the download. So source, so this is the original file. So destination d colon, okay, destination, so download destination. So the file is successfully downloaded and the path is d colon as the drops.pdf. Okay, so this is our okay, so this is our file. Okay, so this is our file. Okay, this is our file on the dump. Okay, so this is our file. This is our file. So the file is actually downloaded. Okay, so the demo is finished. Thanks for listening.